Hello. Next, we discuss the method of backward induction. Okay. So first, we need to discuss what is an optimal strategy. By definition, an optimal strategy maximizes the value function. That is, you should imagine here a bunch of different paths taking us from A to B. For each such path, there is a value function that is the total sum that we have to pay for taking a particular path. And then we want to minimize. In our case, the definition talks about maximization, but since we are talking about cost, we need to minimize the value function. Now, there is an interesting property which I formulate like this. Piece of optimal whole plus optimal remainder is an optimal whole. So what does it mean? Let's take some path, like this one, for example. I call this an optimal whole, okay? And then take a piece of it, like this one, which takes us from A to C. This is the point C. And let us add to that piece an optimal remainder. By an optimal remainder, I call any optimal path taking us from C to B. For example, this could be an optimal path, okay? So if we add a piece of the optimal whole from here to here, plus this red path from C to B, then we obtain, it turns out that the total path will be optimal. And this property takes us to the idea that we can start from the end, find optimal remainders for all states, and then this will give us a solution, okay? Now I'm going to illustrate this idea. Once again, we start from the end when we found the paths going from the previous time point to this point B, then go backwards one step and so on. This is how it works. If we are at this point, then there is only one path going from this point to B. So we need to mark it anyway. And the price that we pay will be 4. Each time we mark something, we need to put the value for the path, for the partial path that we obtain. Okay, so the value for the cost that we have to pay from going to here from here to B will be 4. Then here also there are no other opportunities. This is the only way to go to B, and the cost will be 3. Then if you look at the previous states, there are 1, 2, 3 of them. We need to discuss each of them. So at this upper point, there is only one way, and the total cost is what we had before plus this new contribution, which is 1, and the result is 5. Then for this one, we can go either through the upper leg like that or down, okay? So if you go up, the total cost will be 9, which is 5 plus 4, and here the total cost will be 5, 2 plus 3, okay? So we mark the optimal path. This is the optimal path, and we put red beside it the associated value, 5. This is how much we have to pay. Next, here, there is only one way we can go, so the total will be 9 here. And next, we need to discuss even more points, okay? So for the unique ones, it is easy. 3 plus 5 gives 8. And then if we look at this one, we would have to compare 2 plus 5 and 1 plus 5. Obviously, 1 plus 5 is less. This gives us 6. And we mark only this segment of the road. So continuing like this, we can obtain optimal paths for all states, and the associated numbers are here. You can try to do it on your own, and in the end, this is how much we get, 17, okay? And then we go along those red lines, red arrows that we selected here, and the result is that there is only one optimal strategy that takes us from A to B, and this is how much we have to pay if we follow that strategy. Okay, thank you. Bye.